In these second types of problems, you're going to write and solve direct variation equations. Now, if this were a quiz, it's going to read the exact same way. So make sure that you maybe star this or something, because on a quiz, if you see suppose y varies directly as x, and you don't know what that's telling you what to do, you're really just kind of stuck. I can't coach you through that as a teacher, because that's telling you how to do the problem. That's not reading it aloud to you, which is an accommodation in many places. So suppose y varies directly as x. Well, you know that the direct variation equation is y equals kx. Well, that's not too challenging to memorize. So that y varies directly, so it depends directly on x based on this equation. So we have to write a direct variation equation that connects x to y. And here's what you know. If y is 28, then x is 7. And I could say that reverse too. If x is 7, then y is 28. But either way, I'm going to rewrite the formula with these values in place. Now I know we normally see the number in front of a variable, but for this one I'll write it like that. Well, we had something with 3 letters, 1, 2, 3. I can think of that as being 3 variables. And if I know 2 out of those 3, that'll help me figure out the third. So by figuring out that k, it's like we're going to set ourselves up to come up with a universal equation where it's like y equals some number times x. So go ahead and write that on the right side too, with a little space before the x. So this is simple to solve. I'll divide both sides by 7. And I'll get k is equal to 4. And then just write y equals 4x. Well, not too crazy complicated, but let's check it by plugging 7 in. 4 times 7 does give me 28. So what this means is that if x is 0, y would be 0. If x is 1, then 4 times 1 would give me 4. So we have a direct variation equation connecting x to y. So just to remind you, the wording is confusing, but if you know what a direct variation equation looks like, you can write that down, figure out that you have 2 of the 3 parts, find the third part, and then rewrite it in that form of y equals kx. This is number 1. Here's the information we have for number 1. So let's use this for problem 2. Use the direct variation equation. Well, the direct variation equation we just came up with was y equals 4x. To find x when y is 52. So below my y, I'm going to write 52, because that's what y is, equals 4x. Then I just solve this, dividing both sides by 4, and I will get x is 13. We're done. That's all we had to do for part 2. This is the exact same type of problem, so I'm going to make this an on-your-own problem. I'm going to do both parts 1 and 2, and only briefly talk about it. So if you need to, jump back and see the steps, looking at your notes or either rewatching parts of the video. Pause this video. I'm going to go on the answer in about 5 seconds. Here we go. Well, it's always helpful to rewrite the formula, and I tell you to do that, so don't skip that step. Once we plug in the values of negative 18 and 6, we can solve by dividing both sides by negative 18. And we'll get a fraction for this one. K is going to be negative 1/3. Again, that's the using 2 pieces of information to figure out the third missing piece of information in an equation that only has 3 letters or variables. And then we just have to rewrite it with the k in front of x, because that's the constant of variation. It's our basic rate of change. When we plug in a value of negative 2, negative 1/3 times 2 becomes negative 2/3, and you are done with that problem. The only thing that remains is to talk about some real-world problems. And if you were to come to a quiz question where it says you have to write a direct variation equation, you can't skip that step. I point that out because a lot of the time, you can figure these out by just using some basic division or multiplication. But we have to be able to do these for any type of problem, no matter the numbers they give us, so it's good to go through the steps. Biology. The migration of snow geese varies directly as the number of hours. This hint is giving you a little bit of a heads up that you're talking about y equals kx. So it really means that the migration varies directly based on the hours. And if we usually think about hours, that feels like it's an input. So maybe that is why we would default to x there. A flock of snow geese migrated 375 miles in 7.5 hours. So even though A gives us specifics to use D and T, let's write y equals kx, because we've been practicing that again and again. Well, where do D and T make sense the most? Well, I think distance is going to stand in place of y, because the distance is going to depend on the time that the geese flew. So D equals kt. Now let's substitute in the values that we know. Well, they traveled 375 miles, and I'm going to do times 7.5. And it doesn't matter that it's a decimal, you just stick to the same steps. And you're going to get k is equal to 50. Well, that gives us k. And so we're still dealing with A when we have to rewrite D equals 50 times T. So we've come up with the direct variation equation relating distance and time for the migration of these snow geese. I was told to graph it next. Negatives don't really have any impact here. So we'll just set up the first quadrant. And instead of x, I'm going to write t. And instead of y, I'm going to write d as I label these axes. And let's think about, well, what makes sense? Well, I think if we just go to 5 hours, that's probably enough. Equidistant tick marks for 1, 2, 3, and 4. And then if I plug in 5 times 50 gives me 250. So here's 250, which means I'm going to have 50, 100, 150, 200. And that'll do our job just fine enough. All of these direct variation equations start at 0. So there's 0, 0, the origin. And then here's 5, 250. And I think for our purposes, that graph is good enough. So now we have to estimate how many hours flying time it would take the geese to migrate 3,000 miles. So I mean, if I wanted to get crazy, I could be like, whoa, where would 3,000 be? But I don't think we even have to estimate for this one at all. So here's the equation. Now I know that 3,000 is D equals 50T. Divide both sides by 50. And you're going to get that T is equal to what? 60 hours. Let me double check my zeros that cancel here before I say that's definitely right. 50 over 50 goes away. That goes away, and then 300 divided by 5 is 60. Yeah, so we're good there. So that's doing a word problem with us. I'm not going to bother reading this one aloud or anything. Make this an OYO problem, and I will do everything and have it up in about 5 seconds. So there's all the work for it. I don't even know if I really will talk about it because it's basically the same as the last one. I will point a few things out. There's the direct variation equation. I only plotted a point at 10, 700, so I put my graph to 1,000 with tick marks at 100. And then when I solved it, I got 30 minutes. You can write MINS, but you do not want to write MI. That's miles. And you also do not want to write M because that's meters. This is the assignment that goes with this. Give it a go. I think it will go very smoothly. The only challenging things I see happening is what I warned you about with one thing, the wording, and knowing that you just have to jump right in. And then secondly, also, some of the word problems might trip you up a little bit as they throw different letters at you. But I think other than that, it's going to go smoothly. So have at it.